Good morning, ladies and gentlemen. My name is David Grant, and I'm from the University of New South Wales in Sydney, Australia. And I'm here to talk today about water recycling in the poultry industry, specifically with regards to spin chillers and how we can recycle water and energy from those systems. I'd also like to apologise for not being there in person. I wish I could come along. I had a great time at IAFP last year in Charlotte, and I hope you're having a great time and looking forward to the dinner tonight, and I look forward to seeing you again next year. Here's a quick rundown of today's presentation, and without further ado, let's get into it. Now, the food processing industry in Australia makes up about 1% of our total water consumption, and that actually is about 186 gigalitres per annum. This accounts for about $390 million Australian each year in businesses' consumption with paying for water. Furthermore, if you take into account that Australia has experienced exponential growth in poultry consumption from 1963 to 2013, where we saw consumption increase from 4.2 kilograms per capita up to 44.81 kilograms per capita, more than a tenfold increase. This is at a time where we've actually seen a drop in red meat consumption with beef and pork, and now we're actually seeing chicken consumption being higher than beef consumption in Australia. Then we've also got this problem of Australia's climate. Most of Australia's food is grown along the east coast, where you can see the red markers on the graph, and there's one plant over in Perth on the west coast. And basically, over the last 4 decades, that particular area has been trending down in rainfall. So we've already seen drops in the amount of rainfall. And on top of this, we're also seeing rainfall forecast in Australia showing that in the next 3 months, the chance of rainfall reaching median levels is below 50% for virtually the entire Australian mainland, and in many places, which can be seen by the blue markers, where poultry abattoirs are, we are seeing rainfall predictions being below what is expected compared to previous years. So this creates a dire picture for the Australian market. On one hand, we are seeing situations where growth is exponential, and there have been no new abattoirs built in Australia over the last 10 years, so all the existing capacity has been absorbed by existing production facilities. We're seeing declining rainfall, which is causing water stress at 37.5% of surveyed plants, where they either cannot take in more water from town water supplies, or they cannot discharge more water into either trade waste or environmental flows. And this is coupled at the time where Australia is seeing some of the largest increases in water and energy and gas seen in the modern world, to the point where we now have some of the most expensive commodities in the world. This leads us to a point where we need to work out a new system to recover water and energy in abattoirs. So, if we look at our purpose, the waste hierarchy dictates that at first we should try and prevent or minimize how much water we use. Now, Australian plants are already doing this. Water consumption in US plants is measured in litres per bird, and it's approximately 25 litres per bird, about 6 gallons. In Australia, we do it a bit cheaper, a bit less. We actually managed to operate on 22.12 litres per bird, which is about 15% less than the US value. So that prevention and minimization is already occurring. Now, we can't continue to cut water ad infinitum, because obviously a certain amount of water is required to maintain HACCP protocols when processing a bird. So the burden comes down on our waste hierarchy to reuse and recycling, which are the next ones on our pyramid, which is mainly what our technology focuses on. But we need to understand why food processors don't want to recycle water. And to that, the Australian government has actually done a study into this, and they discovered that besides economic return, the biggest barriers facing food manufacturers is understanding government and water authority regulations, so barriers with regards to getting your technology validated and certified. Some of them also do it for corporate citizenship, just to show that they're to their customers and to the general public that they are taking care of the environment. But interesting to us was this light blue one at the top, which is reliability of supply and quality. So we're talking about plants, that there's some plants out there which are seeking to actually introduce water recycling technologies simply to guarantee supply of water in their particular abattoir or processing plant for that matter. So we really are left with three questions. Is the process going to be cost effective? Is it going to be environmentally and socially sustainable? And what sort of legislation guidance do we have to go through? And these are the barriers that we need to manage in order to make plants want to recycle. So to do this, we came up with a new system. In this particular case, potable water, as it always does, comes into unit operations throughout the plant, usually in an elevated or reduced temperature, such as a scald tank and the spin chiller. Instead of actually just putting this water to trade waste from these unit operations, it's going to be fed into a membrane treatment system, which uses a 0.2 micron aluminium oxide membrane, which will filter out particulate matter and bacteria from the actual wastewater. From there, that wastewater will be returned to the feed stream for that particular unit operation, where it will be blended with potable water to make up for water that it can't be recycled due to concentration. The purpose is not to create a potable effluent, but something which is fit for purpose. It's been through a high quality filter, it's effectively sterile, and we have removed all the contaminants that exist in the tank. However, it's returning back to that tank anyway for use. So whilst there is going to be some concentration, in most cases we're getting greater than 2 log removal. So this isn't going to be a problem, especially in tanks which are drained and cleaned daily. But the general purpose, the focus is to make water as high quality as possible but fit for purpose. Now, before we conducted any experiments, we undertook a triple bottom line analysis to model the impact of introducing spin chiller, wastewater treatment, and energy recovery technologies would have on the process. Now, without going into too much detail, in this particular spiderweb graph, smaller values indicate a better result, but the blue line indicates what is currently operating in your abattoirs, and the smaller concentric circles indicate the 50% to 90% recovery scenarios. And across almost all criteria, we're seeing improvement. Energy consumption, greenhouse gas emission, and water use dropped. Land disturbance increased slightly due to additional capital equipment being built. Gross operating surplus, which is profit, went up, as did water treatment cost per bird went down. Employment, income, both went up as a result of employing new members for the water treatment system, and taxation fell. Australia has a fragmented legislative body with regards to water treatment in food processing plants. Each state and territory has their own food or health authority which manages this, and this becomes a problem when trying to gain certification. For the most part, the New South Wales Food Authority was the most developed, and they currently have a document which is the Water Reuse Guidelines, and for the purposes of this study, that was suitable for providing guidelines for water treatment targets in our pilot. It also reflects water treatment guidelines for other states and territories. So what did we do? Well, the New South Wales Food Authority was able to create a set of water reuse guidelines which provided us targets to work towards. And these are shown on the screen now. We intended to test these using standard methods under the National Accredited Laboratories in Australia, with the exception of microbiological counts which were undertaken with a tempo by bioMario. Water was taken from the spin chiller towards the end of a run, usually within 1 to 2 hours of the end of production for that particular shift. This was to ensure that the wastewater treated was as concentrated as possible and reflective of the worst case scenario. As you can see from this picture, the membranes were able to remove the majority of the contaminants. The container on the left contains a sample of spin chiller concentrated wastewater, which has a creamy white emulsion and an oily feel, whereas the sample on the right is a sample of the filtrate from the membranes and is virtually free of all contaminants that are suspended and has no discernible odor or color. Not to bore you with engineering details, but this is a quick plot of membrane performance, which is a transmembrane pressure or TMP versus time graph of the membrane system. Usually the pressure goes up due to fouling during the operation. However, as we can see here, in the first 2 hours we see an initial spike of TMP before it gradually reduces to remain under 40 for the remainder of the run. This cleaning is most likely due to the fact that the feed solution has a high concentration of sodium hypochlorite in the solution, which is actually used as an antimicrobial agent and a cleaning agent in the membranes. Thus, the membranes are almost being cleaned as they're being used. The Food Authority guidelines also recommended that we test filtrate quality, which was these 6 parameters that you saw before. pH was the most interesting because the guidelines were set between 6.5 and 8.5. However, the majority of the results fell below the 6.5 limit, which was confusing because it should be higher due to the increased neutral point due to the cold water and the pKa shift, and then also because of the fact that sodium hypochlorite had been dosed, which is basic. In an actual situation, we may need to introduce a base in order to pH correct this particular solution. However, from a membrane standpoint, an acidic solution is not going to have a long-term effect on ceramic membrane, as the ceramics are essentially insoluble. The free chlorine was also well outside the New South Wales Food Authority guideline range of 0.2 to 2 milligrams per litre. However, as stated before, this actually has a cleaning effect on the membrane, so we're actually not concerned by this, as well as the fact that this is considered to be normal for processing in the spin chiller. So neither system is affected by this high chlorine level. This would probably be ideal for when this system is used in a plant, as it will actually keep the membranes clean during operation. Turbidity was always below the 1 NTU 95th percentile limit set by the Food Authority, and total suspended solids was always below 10 milligrams per litre. Microbiological tests for total viable count, E. coli, and coliforms were all below 1 most probable number per milliliter. And this wasn't all that surprising. Whilst the membranes are able to filter out anything bigger than 0.2 micron, which is most of your bacteria, as you can see from the feed concentrations, the majority of the tests actually came up negative for almost all of the micro, with only a couple of days where we actually got a detectable total viable count, and in some cases total coliforms in the spin chiller, but they were isolated incidents. The filtrate quality, as you can see, pH was unaffected, and this is unsurprising as the membranes don't remove ions. Turbidity had a 99.8% removal, as did total suspended solids. Free chlorine was unchanged, and BOD saw a 98.5% removal. However, this does have a large error, so we may need to revalidate this result, especially due to the fact that BOD is got a limit from the Food Authority of 10 milligrams per litre. Overall, the system worked. Membranes have shown in this particular system that they can operate well at a flux of 100 LMH, which is considered to be high. Most systems usually operate around the 40 to 60 mark at most. This operation can run sustained for up to 72 hours, which allows for prolonged use of the spin chiller if that's how the business operates. Modelling has shown that the implementation of these technologies and the water and energy recovery that would result would create positive environmental, economic and social impact as a result of poultry abattoirs. So we already begin to see the benefits of undertaking these technologies. It's also compliant with all Australian and overseas legislation that we've seen so far. However, we do have those two issues with regards to pH values and free chlorine. So we may need to talk about dosing more sodium hypochlorite or some sort of other base in order to correct the pH into the correct range. Or we may need to, as with the free chlorine, approach each individual authority and apply for exceptions for these particular cases. In conclusion, in addition to the points I made a moment ago, we're going to see a drop in power and gas and coal consumption in these sites as a result of recycling water, and that's due to the fact that we're going to have reduced electricity consumption as we're no longer labouring ammonia chillers. This will reduce CO2 emissions and improve the sustainability of the process as a whole. LCA analysis also indicates that this is better than the current arrangement environmentally. It also is better than implementing advanced wastewater treatment systems, which is what some plants are currently doing, and actually seeing increases in their wastewater treatment environmental cost. The next step is a larger trial for a longer period of time on site to validate operating parameters. I'd just like to thank Greg Leslie and Julian Cox for the supervision on this project. Without them, I wouldn't be here today. Dr. Pavic and Berlin Avian Laboratories for their support with this. My postdoctoral fellows, Dr. Cox and Dr. Anthony, and all the people at BARDA Australia who have helped out with some of the work that they've done. Finally, again, I wish I could be here. I hope you're having a great time at the conference. My name is David Grant. You can contact me at david.grant@unsw.edu.au if you have any questions. And I look forward to seeing you all in the future. Have a good day.